Today's lesson is about inequalities. The first thing we want to look at is that the solution to an inequality is what can be replaced for the variable to make the sentence true. So any number that we can replace for the variable that makes the inequality true can be called a solution to the inequality. So for example, if we look at x is greater than 5, then 5 is not a solution because 5 is not greater than 5. 4 is not a solution because 4 is not greater than 5. And also, 6 would be a solution because 6 is greater than 5. So we're going to rewrite this inequality into a word sentence, and then we're going to graph it on a number line. The first one says that x is less than 3. We read that sentence as x is less than 3. And if we want to graph that inequality on a number line, we have to first find 3 on the number line, and we're going to make a circle. And in this case, we're going to make an open circle. And the open circle represents that we are not including 3. X is less than 3 means all the numbers less than 3, but not including 3. So we're going to make an open circle. And we're going to shade all the numbers that are less than 3. So less than 3 would mean left. All the numbers less than 3 would be the numbers to the left of 3. The next one says x is greater than or equal to negative 1. X is greater than or equal to negative 1. So we're going to go to the number line and we're going to find negative 1 on the number line. And in this case, since it says greater than or equal to, we're going to include negative 1. So we're going to make a closed circle. And then we're going to shade all the numbers that are greater than negative 1 also, which would be the numbers to the right of negative 1. And the last one says x is less than or equal to 4. X is less than or equal to 4. So we're going to find 4 on the number line. And we're going to make a closed circle. We remember that when it has the or equal to part, we want to put a closed circle. And since it says less than or equal to, we want to shade the numbers that are to the left of 4. The next thing we're going to do is we're going to write an inequality that represents each sentence. So I'm going to give you a sentence, and we're going to write the inequality that matches the sentence. This one says, number 4 says, 5 fewer than a number is at least 12. So 2 things we have to know here. The word fewer than means we need to subtract. So 5 fewer than a number would be a number minus 5. And then it said is at least, and we remember that at least means greater than or equal to. So 5 fewer than a number is at least 12. We would write n minus 5, so n would be the number. N minus 5 is greater than or equal to 12, and that would be my inequality. The next one says the product of a number and 8 is at least 25. So the product means we multiply. We remember that. Everybody should know that. Product means we multiply, and there it is again, is at least, so we know that means greater than or equal to. So the product of a number and 8 would be 8 times n, where n would be the number. 8 times n, or 8n, is at least, so we're going to write greater than or equal to 25. And there's our inequality. So we should be able to translate a sentence into an inequality. The next thing I want you to be able to do is to solve what's called a simple inequality. And in this case, simple does not mean easy. Simple just means that there is only one inequality here. So number 6, we're going to solve this inequality exactly the same way we solve equations. So we solve inequalities the same way that we solve equations, which means we do opposite operations. So I'm going to add 9 to both sides. 13 plus 9 is 22. And then I'm going to divide both sides by 11. and I get y is greater than or equal to 2. I want you to, oh, sorry, not greater than or equal to, just greater than. I want you to notice that the inequality sign comes down with every step. Y is greater than 2. The next one, number 7, we have like terms on each side of the equal sign. So I'm going to subtract 10x from both sides. 7x minus 10x would be negative 3x. Bring down your inequality sign, greater than or equal to. Then we're going to subtract 9 from both sides. So we get negative 3x greater than or equal to negative 21. And then I have to divide both sides by negative 3. So in comes the rule we have to remember about inequalities. The big rule we always have to remember about solving inequalities is that when I multiply, I'm going to write it out for you, multiply, I want you to write it out too. Multiply or divide by a negative number means you switch the sign. Switch the inequality sign. I'm going to write switch the inequality sign. I'm going to put it in a little bubble there so we know that that's important. So when I'm dividing both sides of this inequality by negative 3, I know that instead of x is greater than or equal to, now it's going to become x is less than or equal to 7. Number 8 looks like we have some distributive property to do here. If I multiply negative 3 times 2x, I get negative 6x. Negative 3 times negative 5 would be positive 15. So I have to be careful when I'm distributing a negative. We have to change the sign. And after I distribute, I always look for like terms. So I see 15 plus 1, which would be 16. Then I can subtract 16 from both sides. Negative 6x is greater than or equal to 4 minus 16 would be negative 12. And once again, I'm dividing both sides of this inequality by a negative number. So when I bring down my inequality sign, instead of, notice I'm bringing down the greater than or equal to every time. But since I'm dividing both sides of this inequality by a negative number now, I'm going to switch the greater than or equal to less than or equal to. And negative 12 divided by negative 6 is positive 2. We have one more to do. We have to distribute our negative 2. So remember, distributing a negative means we're switching the sign. Negative 2 times 3x is negative 6x. And negative 2 times 1 is negative 2. And I look for like terms. I see like terms on either side. So I'm going to add 6x to both sides. And I see when I do that, notice what happens. All my variable terms go away. And so we remember when we solve equations, sometimes this happens also. And when this happens, we get either a true sentence or we get a false sentence. And in this case, negative 2 is not greater than 7. So we're going to say that that's a false sentence. And when we see that it's a false sentence and I have no variables left, I want to say that there is no solution to this inequality. Okay, so we solved some simple inequalities. Now we're going to go in and we're going to solve some compound inequalities. We're going to talk about what those mean. Compound inequality is when two inequalities are joined by either the words and or. And when an inequality is joined by the word and, it looks like this first example here. It looks like it's kind of smushed together with the variable in the middle. And you have the variable in the middle and one inequality going to the right. It says x is less than 1. And then you also have an inequality starting in the middle and going to the left. So this one says x is, if we write it out as a sentence, it says x is less than 1 and x is greater than or equal to negative 2. So how do we graph this on the number line? We graph a compound inequality when it's an and. When it's an and, we graph the intersection of the two. The intersection means what they have in common, the numbers that they share. So where are the numbers that are less than 1 and also greater than negative 2? So we could do one less than 1 above and another one below. X is greater than greater than or equal to -2, and we can look and see where they overlap. That's what we're looking for. So that we see that they overlap in between the two. So I'm going to put a closed circle on -2, put an open circle on 1, and we know why, and I'm going to shade all the numbers in between. You don't have to do them separately, one on the top and one on the bottom, but if that helps you to find the intersection of the two, then you should do that. So when we graph an and compound inequality, we want to graph the intersection. In other words, where do they overlap? What do they have in common? Okay, the next one is the one joined by the word or, and we can see that there's an or in this sentence. It says x is less than -1 or x is greater than or equal to 2. And this is an or compound inequality. And so when we graph an or compound inequality, we graph what's called the union of the two. The union means both together. So we don't have to worry in this case when we're graphing an or whether they intersect or not. We just graph both of them together on the number line. And if they intersect, then great. If they don't intersect, that's okay too. So I'm going to graph x is less than -1. So I'm going to put an open circle on -1, and I'm going to graph to the left of -1. And then I'm going to do on the same number line, I'm going to graph x is greater than or equal to 2. So I'm going to put a closed circle on 2, and I'm going to shade to the right. So notice there is no intersection here between these two inequalities, and that's okay. We're not worried about the intersection. We're worried about the union, which means any number that's to the left of -1 and any number to the right of 2 would be a solution to this inequality. So now we're going to solve a compound inequality. And notice that when it doesn't say or, notice it has the variable in the middle and one going to the right, one going to the left. This is how we know that this is an and compound inequality. So when we graph the solutions on the number line, we only graph the intersection of the two inequalities. So I'm going to add 8 to both sides. And in this case, I have 3 sides, don't I? I have the middle. I need to add 8 to the middle. I need to add it to both sides, going to the right and going to the left. So I get 3t, and I need to bring down my inequality symbols. 10 plus 8 is 18. -2 plus 8 is 6. And then I have to divide everything by 3 again. So t is less than or equal to 6, greater than or equal to 2. And then I have my answer already in the form that I want it, as an and compound inequality. And if I'm going to graph the solutions on the number line, I can do that. So I'm going to put a closed circle on 2, put a closed circle on 6. The numbers that are greater than or equal to 2 and also less than or equal to 6 are the numbers in between. Okay, now we're going to do an or. And when we're solving an or compound inequality, we are just solving each one separately. So I'm going to solve these two inequalities and get the solutions and then talk about what the solutions mean. So notice I'm going to add 3 to both sides. Subtract 3 to both sides. 5 minus 3 is 2, and then I'm going to divide both sides by 2, and I get x is less than or equal to 1. Or, then I'm going to go to the other inequality, and I'm going to solve that inequality. So I add 7 to both sides. 9 plus 7 is 16. Divide both sides by 4. And I get x is greater than 4. So when I graph these solutions on the number line, so this is how I write my answer, just like this. X is less than or equal to 1, or x is greater than 4. Write it out just like that. And when you graph your solutions, 2, 3, 4. When you graph your solutions on the number line, we put a closed circle. We're going to graph x is less than 1. Not worrying about where they intersect, remember, we're graphing the union. Or means we want the union of the two, which means we just put them together on the number line. So I graphed x is less than or equal to 1. And I'm going to graph x is greater than 4. So I put an open circle at 4. And I'm going to shade to the right because we want greater than. So I want you to notice that the and compound inequality is shaded in between. and the or compound inequality is shaded on the outsides.